Hey everybody, this is Zach Does All the Things. Let's get to busting our brains. Today we're talking about this problem right here. In this problem, each one of the letters represents a different number between 1 and 10. So A, B, C, D, E, F, and then G, 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 G. We have to figure out which digit between 1 and 10 each one of those letters is. So I invite you to stop the video right now and try to figure it out for yourself, but come back for the answer because it's pretty interesting. So here's the deal. A, B, C, D times F equals G, 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 G. The first thing we want to do is add some real numbers to this equation. So we can take A, B, C, D, E times F and equate it to G times 1, 1, 1, 1, 1, 1. That's essentially the same thing as saying whatever number G is times 111,111 equals G, 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 G. It makes this easier because we can reduce down to just one variable G, and we're just multiplying by 1, which is the property of identity. What's also cool about this string of ones is it's only divisible by 3 and 7. So if we wanted to make it its smallest form, we could break it into G times 3 times 7 times 5,291. Did a little quick calculating for you there. And notice that I didn't talk about multiplying by 1 or 0 because again that's identity or 0, so they're really not helpful in this situation. What we get is an equation that looks more like this. From here, we can use this equation to basically go through trial and error with each one of the digits 1 through 9 and figure out exactly which one works. Another given we should think about before we get to trying out these numbers is the relationship between F and G. If G all by itself is a multiple of F, let's say that G is 6 and F is 2, that would mean that A, B, C, D, E would all be the same numbers. See? So if G ever ends up being a multiple of F in the equation, we can assume that's incorrect because A, B, C, D, E can't end up being the same 5 digits. So let's work down the line here. If F is 0, then the entire thing is a wash because you've multiplied it by 0, you get 0. If F is 1, then it wouldn't matter what G is, it would always be a multiple and therefore incorrect. Now when we get to 2, we know 2 doesn't work because if F were 2, then G would have to be a multiple of 2 in order to divide the entire thing evenly, which means that it can't be correct because it is a multiple. You following that? Essentially 2, 4, and 8 don't work because if you were to choose one of those, G would have to be a corresponding multiple, and that would cause A, B, C, D, E to end up being the same number. So we can avoid those. We've already ruled out 0, 1, 2, 4, and 8. What else can we rule out? 5. And the reason for that is if you choose 5 for F, you also have to have a multiple of 5 for G if you want it to divide evenly. And once again, if G is a multiple of F, it ain't gonna work. So what's left? 3, 7, and 9? Okay, so what if we used 3? What's cool about this is 3 is already in our equation, which makes it easily divisible out of the equation, making A, B, C, D, E, G times 7 times 5,291. Well, that's easy. Let's just put 7 and 5,291 together, and we get G times 37,037. Here's the important part about that number. There's a 0 in the middle. That's not good. That means that this is a repeating pattern, and anytime we try to multiply G, we're gonna get a repeating pattern. That's not great for A, B, C, D, E because each one of the integers has to be different. So we move on. We could talk about 6 for a second, but you're gonna run into similar problems because it's a multiple of 3. The same thing goes for 9 as well. All those multiples of 3 will end up with the same problem of a repeating pattern that gives us too much of the same integer. I guess that leaves us with one option for what F could be, and that's the number 7. It's a prime number, so there's no multiples that we have to worry about, and it's already present in our equation, which makes it easily divisible, leaving us with 3 times 5,291, or G times 15,873. So cool, we've got F figured out at least. Now what about G? Well, let's think about this for a second. First thing I'm noticing is that we can't use 7, 8, or 9 because if you multiplied 15,873 times any of those numbers, you would get more than a 5-digit number. And that won't fit into the A, B, C, D, E that we're trying to figure out. So those 3 are out for sure. We also can't use 1 because if G was 1, then 1 could not appear in A, B, C, D, E, and it definitely would if we were multiplying it by 15,000. 5 has a similar issue because if you multiply 5 by 3, you're gonna end up with 5 again in the number, so definitely not 5. That leaves us with only 4 digits that we can use for G, and that's 2, 3, 4, and 6. If you plug each one of those into the equation, you can find that 2 doesn't work because there's a repeated 7. 3 doesn't work because there's another repeated 7 in there. 4 doesn't work because 4 pops up in A, B, C, D, E. And that leaves only 6 with 7 different individual digits. That looks like this. 95,238 times 7 equals 666,666. That seems like a lot of work to get to that simple answer, but it was fun, right? That's how you figure it out. Trial and error, a little bit of logic, and there you have it, your brain busted. This has been Zach Does All the Things. Thank you so much for watching. Please subscribe, like, comment, tell me what you want to see next. And until next time, see you then.